Alright, good day everybody. One more short video before we get stuck into subnetting properly. In this video I want to show you the 3 things we're going to calculate to determine how we're doing with our subnetting. The first formula we're going to need is to work out the number of new subnets we're going to be creating. The next one is going to tell us the number of valid host addresses that are going to be in each subnet. And the third formula is something called the increment, which helps us work out where our new subnets are going to begin and where they're going to end. Now these 3 formula that I'm going to show you do rely on understanding exponents. So if you're not 100% comfortable with exponents, jump back to the previous video where I took that detour during the binary decimal conversion stuff to show you how the exponents are structured. But assuming you're okay with that, let's move along. So the first formula is 2 to the power of n, where n is going to be the number of new network bits we're going to be creating when we extend the subnet mask in the next video. So whenever we create a new binary 1 in the subnet mask, that is going to be an n bit, and we will keep track of that when we do the subnetting. And by substituting that into this exponent, we will get the number of new networks we're creating. Then the next formula is 2 to the power of h minus 2. I just want to make sure that we're all happy that we're going to work out 2 to the h before we subtract the 2. So if you want to write it as 2 to the h in brackets and then the minus 2 outside of the brackets, because you know BODMAS and all that good stuff, it'll help you to make sure you remember to work that out first before the minus 2. And h is the host bits that are going to be left behind in the subnet mask. Now the host bits will be the binary zeros that we have not changed. And the number of those will help us work out how many hosts we're going to have. Now please be aware we have to remember to minus 2, because every subnet we create has a network address and a broadcast address. And those 2 addresses we cannot give out to hosts. So the more networks we'll create, the more minus 2 addresses we're going to have. But that is the trade-off for subnetting. And then finally, the increment, 2 to the power of I, where I is the host bits left behind in just the octet we worked in. This is going to be a bit more useful later on, but I'll explain why in a moment. But whichever octet I was playing around with for the subnet mask, and you'll see it later in the next few videos, those zeros left behind are the increment. Now if there's more zeros in another octet, we leave them alone. It's just the octet we worked in. And to be honest, you're only going to really appreciate this formula's rule properly when we do Class A and Class B subnetting. When we do Class C, the octet we work in is going to be the very last one. So there's going to be no difference between the zeros for the host bit and the zeros for the increment. But you'll see when we do Class B and Class A later on in another video, you're going to really appreciate that important little caveat that it only is in the octet we worked in. Alright, I'll probably refer back to this point in those videos, but just remember it for now. So, quick recap, number of subnets, 2 to the power of n. Number of hosts per subnet, 2 to the power of h minus 2. And the increment is 2 to the power of I. Yeah, it was a bit of a short one, but thanks for bearing with me because these formula are going to be super helpful. And this video saves us a bit of time in the other videos where you might be okay with this already. But otherwise, thanks for sticking with me through this. I appreciate it. And the next video is going to be more exciting. We're actually going to do some subnetting. Thanks for watching though, and catch you in the next one.